Welcome back to some more Nick Does Maths with me, Nick. Today, we're going to go do some collisions. A ball is going to go pinging around this box and we're going to find out what happens. There's a whole blurb of text that goes with this question, but really what it boils down to is this. We send a ball coming in. This is a top-down view on a smooth surface and it's going to hit these two smooth walls. It's going to come in at 6 meters per second at an angle alpha, ping off at an angle beta, ping off here. What do we know? We know that tan alpha is 4/3. We know that tan beta is 1/3. We know the coefficient of restitution at this point is 1/2. We do not know the coefficient of restitution between the ball and the AB. So part one is we're going to show that the coefficient of restitution has to be a quarter for this to work, for this geometry, for these two angles to be the way they are. And then we're going to find the speed of the particle after it hits this wall, with some dodgy handwriting thrown in. Let's see what we can do. Right, first of all, let's look at our velocity as we come in. We might want to figure a few things out, which is if tan alpha is 4/3, sine alpha is 4/5, cos alpha is 3/5, and if tan beta is 1/3, that will tell me that sine alpha is 1/√10, cos alpha is 3/√10, right? We're just creating these little triangles. Sine over cos, 4, 3, 5 for alpha, and for beta, 1, 3, √10. All right, and that's just a standard thing that we do a lot in mechanics, whether it's further maths or single maths, so that you don't have to go, oh, what's the inverse tan, oh, calculator, and then get these horrible rounding errors. No. We're going to do it with the exact values, which you can do this way. Right, so what is our velocity coming into the impact? Well, before we're coming in at 6 cos alpha, which is 18/5, and we're coming down at 6 sine alpha, which will be minus 24/5. Okay? And then afterwards, after the impact, we're going to be leaving at, don't know, je ne sais pas. But, so let's call this one here U maybe, and we're going to be leaving at U cos beta and U sine beta. Just realized that I've been saying, there we go. So sine beta is what we're leaving with, cos beta is what we're coming in with. Okay, brilliant, lovely. Well, this is all about making sure it all works for me, so let's have a look at some conservations. Now, the impact is only happening really vertically, right? That's where my impact's happening, so my horizontal components should not change. So if I look at the horizontal components, 18/5 is equal to 3u over square root of 10. So that's quite nice. So that does tell me that u is 6√10/5. Next, we actually have to deal with the collision. So the speed of approach of the ball and the wall is 24/5. Times that by e will give us our speed of separation, which is u over √10, which is 6/5. And this is how we're going to deal with that. E is therefore, times both sides by 5, divide by 24, is 6/24 is a quarter. Lovely. Excellent. We can't do conservation of momentum here because some of the momentum of the ball is transferred into this wall, and so we can't just do conservation of momentum. We don't know what's going on there, but we are going to use this coefficient of restitution and the geometry that we are given. All right, so at this point in time, actually I could probably put this in, couldn't I? What this is it's 18/5, we know that. and that will then be 6 over 5. If we put that in, there we go. So we now know what's going in as we come in here. 18 over 5 and 6 over 5. And now we need to figure out what's going to happen as I leave here on that velocity there. So I'm just going to do it with component vectors, components of the vector. Call it xy. And now we go again. However, this time, because the collision is with a vertical wall, right, the impact happens horizontally. So the component that's not going to change is the vertical component. So I know that y has to equal to 6 over 5. And then it's quite simple. Speed of approach, it's approaching at 18 over 5 meters per second. Times that by your coefficient of restitution, and that will give you your speed of separation, which is going to be x. Now we are going to have to put in the distances ourselves, so that gives me, it gives me x is 9 over 5. However, we do know that we are heading off to the left. So we are heading off to the left, so technically it's minus 9 over 5. All right? But the question doesn't want the velocity. That's not what we're asking for. We are asking for le speed, la vitesse, the whoosh. How do we get the whoosh? It is the magnitude of this vector. So what we actually want is the speed is square root of 81 over 25 plus 36 over 25, which is square root of 117 over 25. 117 is divisible by 9, so that's nice. What is it, 13? Yes. So this comes out as 3 root 13 and root 25 over 5 meters per second. Bish, bash, bosharoonie. Right, bunch of stuff going on, but always just do it one step at a time. I've got this collision, I've got this collision. And always think to yourself, which direction is the collision happening in? Because normally these questions are set up so one of those directions doesn't change. So if we're hitting a horizontal surface, your horizontal velocity won't change. Your horizontal component of velocity won't change. If you're hitting a vertical surface, the impact happens horizontally, so there is no impulse, there is no force acting on you vertically, so your vertical component of velocity won't change. Just remember that, and you'll be good. I'm Nick. This is maths. More maths, lots of maths. It's mechanics at the moment. We're on a spree. Join me next time.